For more problems and videos like this for linear algebra, you can take a look at Sarai Studies. Link is in the description box. When we perform elementary row operations, it's really just a fancy way of saying just basic row operations on a matrix, it doesn't change the value of the matrix. It's still the same matrix, it just looks different. What we can do is we can switch rows. So for example, let's say that I have a matrix that looks like this. I can simply just switch row 1 and row 2. So the notation for that is row 1, switch with row 2. That's literally just going to switch these rows, and that's it. This is still the same matrix as this one. The second operation that we can do is multiply a row by a non-zero number. So multiply a row by any number that's not 0. So for example, let's say that I want to multiply row 1 times 2. Well, then the notation for that is 2 row 1 is going to be my new row 1. Some people say row 1 is equal to 2 row 1. That doesn't mean that it's equal to 2 row 1. It just means that we're rewriting row 1 as 2 times row 1. So all that means is multiply 2 times these values. So this is going to be 2 times 1, that's 2. Then 2 times -1, that's going to be -2. 2 times 0, that's 0. And then 2 times 0, that's 0. That's going to be my new row 1. So this is what it's talking about, saying our new row 1 is 2 times the old row 1. And then all of the other rows stay the same because the only thing we changed was row 1. So that's the only row that should be different. This is still the same matrix as this one. Now this is something you might find useful. Note that the rule says that we can only multiply. So if we have this 2 and I want to make this a 1, then ideally I would divide by 2. But we can't divide, we can only multiply. But we can rewrite division in terms of multiplication. We could just do times 1/2 because that's the same thing as dividing by 2. So in this case, I could do 1/2 of row 3, because this is row 3, and then have that be my new row 3. So that means I take everything in row 3 and multiply by 1/2, which is just a fancy way of saying, hey, you're just dividing by 2. So this stays 0, this stays 0, this goes to 1/2, and then this just becomes -1. So that's going to be my new row 3. In practice, I just do R3 divided by 2, like everybody knows what you mean. But technically speaking, this is the way that we have to do it because there's nothing that says we can divide. It's just multiplication. We call this row scaling because we're scaling rows. We're just making it bigger or smaller. But this is the exact same thing as this. And finally, the last operation that we can do is we can add a multiple of one row to another row. Well, what does that look like? Well, it's the same thing that I did here, a multiple of one row. So this is 2 times one row. That's a multiple of one row. So we're going to do that. And we're just adding another row. So first of all, this looks like this. This is 2, -2, and these stay 0. And then I want to add this to, let's say, row 3 and have that be my new row 3. So I like to just write everything down. So if this is 2 times row 1, that's 2, -2, 0, 0. I'm adding row 3, 2 plus 0, that's 0. This is -2, 0 plus 1, that's 1. This is -2. So then that becomes whatever's here, my new row 3. So the only thing I changed was row 3. So these two rows stay the same. And then since the only thing I changed is row 3, instead of having this, I'm going to have my new row 3. And this is still the same matrix as this. It just looks different. So we will use these tools to follow the recipes needed to get our matrices to look like row echelon form or reduced row echelon form so that we can easily extract solutions to our systems of equations. So I'll see you in the next video.